You're walking alone on a quiet trail at dusk, and somewhere in the brush, something big shifts its weight. You freeze. And a second later, you hear it running the other way. No claws unsheathed, no roar, nothing chasing it off except the sound and shape of you. Which is strange, if you actually think about it. You're not fast, you don't have fangs, your nails couldn't threaten a house cat. So why does so much of the animal kingdom still treat the mere presence of a human as something worth fleeing from immediately? The answer isn't really about what you look like. It's about what your species has spent the last 200,000 years teaching every predator and prey animal on Earth to assume. Let's start with something researchers have only recently been able to measure directly, because it turns out this fear isn't some vague cultural assumption. It's a documented, quantifiable phenomenon. In 2019, ecologists Liana Zanet and Michael Clinchy, working with colleagues in South Africa's Greater Kruger region, set up hidden speakers at watering holes and played recordings to wildlife, including large predators like lions, comparing animal responses to the sound of humans calmly talking versus the sound of actual lion roars, growls, and even gunshots. The results were almost absurd. Across the vast majority of species recorded, animals fled far more readily and abandoned the watering hole far faster at the sound of ordinary human voices than they did at the sound of lions, historically one of the most dangerous predators on the entire continent. Some species were roughly twice as likely to flee from a calm conversation than from a lion's roar. Let that sink in for a second. In the mind of an African elephant or a kudu, the scariest sound in the entire ecosystem isn't a predator's roar, it's you, chatting quietly about your day. So if modern animals are already this afraid of us, where did that fear actually come from? Because humans clearly weren't always the terrifying thing in the room. This is where the story rewinds a very long way. Early hominins, going back millions of years, were not the apex predators of their environment. Fossil evidence, including bite marks and puncture wounds found on early hominin skulls matching the tooth spacing of large cats, suggests our ancient ancestors were, for a significant stretch of prehistory, prey just as often as they were predators. We weren't the scary thing stalking the grasslands. We were frequently the thing being stalked, which makes the eventual reversal of that relationship even more remarkable. Because somewhere along the way, an animal that used to run from predators became the animal every other predator learned to run from instead. Now here's the part nobody talks about. The shift didn't happen because humans faster, stronger, or physically more dangerous in any conventional sense. It happened because we found a way to cheat. Researcher Daniel Lieberman at Harvard has spent decades studying a hunting strategy called persistence hunting, still practiced in a limited, well-documented form by some modern hunter-gatherer groups, including certain sand communities in the Kalahari. The strategy is almost embarrassingly simple. Humans, with our unusually efficient bipedal gait, dense network of sweat glands, and relatively hairless skin, are exceptional at shedding body heat during sustained exertion, in a way most four-legged mammals simply are not. A healthy human in the right conditions can chase an animal like a kudu or an antelope for hours in the heat of the day, not by outrunning it in a sprint, which we'd lose badly, but by never letting it fully cool down and rest, till the animal's body literally overheats to the point of collapse. We weren't the fastest predator on the savanna. We were the most patient one, and patience applied consistently enough turned out to be its own kind of terrifying. And persistence hunting was only one piece of a much bigger puzzle, because at some point, humans acquired something no predator on the planet had ever wielded before: controlled fire. Archaeological evidence for regular, controlled fire use by hominins dates back at least 1 million years, with some sites suggesting even earlier sporadic use. And once fire became a reliable tool rather than an occasional accident, it fundamentally rewrote the rules of the entire ecosystem. Fire let humans cook food, which increased caloric intake and almost certainly supported the energy-hungry brain growth that followed. But fire also did something far more immediately terrifying to every other species nearby. It let humans control the landscape itself, driving animals out of hiding places, funneling herds toward ambush points, and claiming safe territory after dark that had belonged exclusively to nocturnal predators for millions of years before we showed up with a burning branch. No other animal on Earth had ever shown up to a predator-prey relationship holding a tool that could reshape the terrain, extend the working day past sunset, and keep larger, stronger nighttime predators at a permanent, uneasy distance. Fire didn't just cook dinner. It quietly announced that the old rules of who owned the dark didn't apply to us anymore. And it wasn't only prey animals that ended up on the losing side of this new arrangement. Large predators that once had no natural rivals found themselves displaced too. Cave bears, once widespread across Ice Age Europe, and cave lions, close relatives of modern lions that hunted across Eurasia for hundreds of thousands of years, Both declined sharply and eventually vanished within a period that closely overlaps with the expansion of anatomically modern humans across the same territory, roughly between 40 and 20,000 years ago. Researchers studying these extinctions generally point to a mix of factors, including climate shifts at the end of the last ice age. But competition with humans for cave shelters, prime hunting grounds, and prey animals is consistently cited as a contributing pressure. It's a strange thing to sit with. For a huge stretch of prehistory, humans weren't just avoiding predators or occasionally outcompeting them for a meal. In some regions, we were quietly displacing animals that had, until recently, been among the most dominant hunters on the entire continent. But wait, persistence hunting alone doesn't explain a fear this widespread, across continents, across species that never even lived near a Kalahari hunter. What else was going on? This is where weapons enter the story, and they change everything about the predator-prey relationship in a way almost no other species on Earth has ever managed. Every other major predator, from lions to wolves to crocodiles, has to get physically close enough to bite, claw, or grapple with its prey, which means prey animals evolved fear responses calibrated to a predator's proximity, size, and speed. Humans broke that calibration entirely. Archaeological evidence for projectile weapons, including sharpened spear points and later spear throwers known as atlatls, dating back tens of thousands of years, and eventually bows and arrows, meant humans could kill from a distance most predators could never achieve. An animal's ancient instinct to judge danger by how close, how fast, and how physically imposing a threat looked simply didn't account for a creature that could end its life from 30 meters away while barely breaking a sweat. We weren't just a new predator. We were a predator prey animals had no evolved template for assessing correctly. And that mismatch, repeated across tens of thousands of years and tens of thousands of encounters, is a huge part of how run from the humans immediately, don't wait to assess, became such a widespread, deeply encoded instinct. Here's a pattern interrupt worth sitting with. Somewhere out there, an animal's entire evolutionary threat detection system has a permanent hardwired asterisk next to it that just says, humans don't follow the normal rules, don't bother finding out why. And it wasn't just individual toughness or clever technology, either. It was coordination on a scale genuinely unusual in the animal kingdom. Researchers studying cooperative behavior in early human hunting groups have pointed out that while other species, including wolves and orcas, absolutely do hunt cooperatively, human coordination added something extra. Complex planning communicated in advance through language, allowing groups to execute multi-stage strategies, such as driving animals toward cliffs, natural bottlenecks, or waiting ambush parties positioned well before the herd ever arrived. Archaeological sites in places like Head-Smashed-In Buffalo Jump in modern-day Alberta, Canada, used by indigenous hunters for thousands of years, show evidence of exactly this kind of strategy, with entire bison herds driven at speed toward a cliff edge by coordinated groups positioned to control the animal's direction of panic. A predator that can verbally plan an ambush days in advance, assign roles to different members of the hunting party, and execute a strategy no single animal could pull off alone, represents a level of predatory coordination most prey species simply had no precedent for surviving. Now here's where the evidence gets almost uncomfortable, because this isn't just about individual hunts, it's about what happened to entire ecosystems once humans arrived in them. Paleontologist Paul Martin proposed what's become known as the overkill hypothesis as early as the 1960s, arguing that the timing of massive megafauna extinctions across multiple continents lines up suspiciously well with the timing of human arrival in those regions. In North America and South America, a huge wave of large mammal extinctions, including mammoths, giant ground sloths, and saber-toothed cats, occurred roughly between 13 and 10,000 years ago, closely tracking the spread of human populations across the continent. In Australia, a similar pattern shows up even earlier, with large marsupial megafauna disappearing in the tens of thousands of years following human arrival on the continent, estimated at roughly 50,000 years ago. The overkill hypothesis remains genuinely debated among researchers, with some arguing climate change played an equal or larger role in these extinctions. And the honest scientific answer is that it was very likely some combination of both factors working together. But the correlation itself, humans consistently showing up shortly, before entire categories of enormous animals start disappearing, appears again and again across multiple unconnected continents, which is exactly the kind of repeated pattern that makes ecologists uncomfortable dismissing as coincidence. And if this fear really is a learned, generationally reinforced response to sustained hunting pressure rather than some fixed genetic constant, there's an obvious way to test that idea. What happens when the pressure disappears? It turns out the fear can fade remarkably quickly. Researchers studying wildlife behavior in areas with long-standing hunting bans, protected reserves, and low human-caused mortality have documented measurably reduced flight distances in various species, meaning animals tolerate human presence far more closely before fleeing, compared to populations of the same species still living under active hunting pressure nearby. This is part of why animals in many national parks will calmly graze within clear view of tourists and vehicles, while the same species just outside the park boundary, in areas where hunting is legal, will bolt at the first hint of a human silhouette on the horizon. The fear was never permanently welded into the species. It's closer to a running calculation, constantly being updated based on how dangerous humans have actually proven to be, generation after generation in that specific place. Remove the danger consistently enough for long enough, and the caution genuinely starts to relax. But wait, if humans were really this dangerous everywhere they went, shouldn't every animal on Earth have evolved an instinctive fear of us by now? Why does that clearly not seem to be true? This is the counterexample that actually strengthens the whole argument once you understand it properly. Fear of humans isn't some universal genetic instinct hardwired identically into every species on the planet. It has to be learned or evolved through sustained predation pressure over generations, which means animals in places humans hadn't reached yet had no reason to develop it at all. The most famous example is almost painfully tragic. The dodo, native to the island of Mauritius, evolved for millions of years in complete isolation from humans and from any significant land predators at all, which meant it had absolutely no instinctive fear of large approaching animals. When Dutch sailors first arrived in the late 16th century, accounts describe dodos walking directly up to humans with no apparent alarm, having simply never needed a threat response for anything resembling us. Within roughly a century of sustained human contact, hunting, and the introduction of invasive species like rats and pigs that raided their nests, the dodo was extinct. A nearly identical story played out with the moa in New Zealand, a group of large flightless birds that had thrived for millions of years with no mammalian predators at all, until Polynesian settlers, the ancestors of the Maori, arrived roughly 700 to 800 years ago. Within just a few centuries, remarkably fast on an evolutionary timescale, every species of moa had been hunted into extinction, partly because the birds simply had no instinctive framework for recognizing a walking, upright predator as a threat worth fleeing from immediately. So the fear we're talking about isn't some universal constant humming through every animal's DNA. It's a lesson, learned the absolute hardest way possible, by every population of animals that ever crossed paths with sustained human hunting pressure. And tragically, unlearned populations paid for that ignorance catastrophically and permanently. And this learned wariness didn't stay locked in the distant past. It's still visibly, measurably active in animal populations today, sometimes in startlingly specific ways. Wildlife biologist John Marsloff at the University of Washington conducted a now well-known series of experiments starting in the mid-2000s in which researchers wore distinctive rubber masks while trapping and briefly handling wild crows for banding and research purposes, an experience the birds clearly did not enjoy. Remarkably, crows that had been trapped by a researcher wearing a specific mask scold and dive-bomb anyone wearing that same mask for years afterward, even individuals who had never personally handled a single bird. Even more strikingly, Marsloff's team found evidence that this learned hostility spread to crows who hadn't even witnessed the original trapping, suggesting the birds were socially transmitting information about which specific human faces to treat as dangerous. If a crow can hold a multi-year grudge against a specific human face, and teach that grudge to other crows who weren't even there, it becomes a lot easier to imagine how over hundreds of thousands of years and countless generations, an entire species could end up with humans, generally are dangerous, baked into its instincts rather than its individual memory. Now here's a question worth sitting with directly. Once a population does learn this fear, how fast does it actually spread, and how deeply does it get encoded? Researchers studying what's sometimes called the landscape of fear, a term popularized by ecologists including Joel Brown and William Ripple, describe how the mere presence of a dangerous predator, without a single kill actually occurring, can reshape an entire ecosystem's behavior, foraging patterns, and even physiology, simply because prey animals reorganize their lives around avoidance. Studies on wolves reintroduced to Yellowstone National Park in the mid-1990s famously demonstrated this effect with elk populations, which shifted their grazing patterns away from open valleys and riverbanks, specifically to avoid areas where wolves could easily ambush them. Changes that rippled outward into vegetation growth and even river erosion patterns. If a reintroduced wolf population can restructure an entire national park's ecology through fear alone, consider what 200,000 years of sustained, Technologically escalating human predation pressure, spread across every inhabited continent on the planet, could plausibly due to the collective threat assessment instincts of nearly every prey species we ever encountered. And in 2015, a team led by conservation scientist Chris Derrimont published research in the journal Science, formally quantifying exactly how extreme human predation actually is compared to every other predator on Earth. Analyzing data across hundreds of species and ecosystems, the study found that humans kill adult prey populations, including fish and large land mammals, at rates dramatically higher than other predators typically achieve, in some cases estimated at many times the predation rate of comparable non-human carnivores hunting similar prey. The researchers coined a specific term for what humans had effectively become across the natural world. Not simply a predator, but a super predator, uniquely capable of targeting adult prey in numbers, and at a pace that no natural predator population had ever achieved before us. Most predators over evolutionary time settle into something resembling a sustainable equilibrium with their prey population, because overhunting eventually starves the predator too. Humans, armed with technology, cooperation, and long-range weapons, largely escaped that natural feedback loop, at least for most of our recent history. A saber-toothed cat learned, generation after generation, that the slow, upright animals near the grass fires were worth avoiding. A dodo never learned anything at all because it never had the chance. A wolf reintroduced to Yellowstone rearranged an elk herd's entire relationship with open ground, using nothing but its presence. A kudu at a South African watering hole, according to actual recorded data, will run faster from a stranger's calm voice than from an actual lion's roar. Every single one of these is the same underlying lesson, learned at wildly different speeds by wildly different species, across wildly different corners of the planet. Humans broke the rules every other predator had to follow, and nature, generation after generation, quietly updated its threat assessment accordingly. Here's the twist worth sitting with as we close this out. That instinctive fear animals show around humans today isn't really about your teeth, your claws, or your speed, none of which were ever remotely competitive. It's an inherited memory, passed down not through direct experience, but through selection pressure, favoring the individuals and species who happen to treat the upright, patient, occasionally weapon-wielding primate as something worth avoiding on sight. The animals that didn't inherit that instinct, or never had the generations required to develop it, are disproportionately the ones who no longer exist to pass anything down at all. Which brings us back to that trail at dusk, the rustle in the brush. The sound of something large deciding, without waiting to confirm anything about you personally, that fleeing was the safer bet. It wasn't reacting to you as an individual. It was reacting to roughly 200,000 years of inherited caution, distilled down into a single instinctive decision made in a fraction of a second. You didn't do anything threatening tonight. Your species did, a very long time ago, and the message never stopped traveling. Fear doesn't need a memory. It just needs enough ancestors who didn't survive without one.